that we did before. The state province ID is 9. You have seen this as our value 9. So if you check our histogram, so you can see the range high key, it's a direct hit, exact match of the histogram. You will get 4,564 records as equal. So likewise, you can do the same thing and check that predicate value in this query in that histogram. So output I have given here to save the time. So state province ID 9, you will get 4,564 records. Postal code 91502, you will get 194 records. City Burbank, you will get 196 equal rows. Then we need to do some calculation here. We need to calculate something called selectivity. We have seen the concept, under concept, the selectivity. So how do you calculate the selectivity? Number of rows which will output by the predicate divided by number of rows of the table. So you will get this figure. So higher value, which is similar to density. Value is higher means, close to 1 means it gives you more duplicate values. So likewise, you calculate the selectivity for all these 3 predicates and then multiply all these 3 predicates and multiply with tuple, actually this is tuple cardinality, which is the total number of records of the table. And if you multiply these all together, you will get 0.45, which is less than 1, so that query optimizer assumes it's 1. So that's how the estimated number of rows 1 came in. Now let's execute the same query with new Cardinality Estimator model. I'm already in SQL Server 2016, so by default new CE model is enabled. So I don't have to use the query trace flag here. At this time, same number of rows, 194. Index scan, and you can see number of estimated number of rows is how much? 13.4694. In earlier case 1. Now 13.5. Still not good, but it's better than the legacy model. So how this time it calculated? Okay, this time also it goes through the same process. Going through the histogram of the statistics object and look for the value and then calculate the selectivity. And then there's another difference here. Rather than just calculating the selectivity, you start with the lowest figure of the selectivity, which is 009890, the lowest figure of the selectivity, which is the figure for selectivity of postal code, and then get the next higher value, higher selectivity, which is the city selectivity. You get the square root, and then look at the next higher value, which is obviously state province ID. You get the double square root of the square root of the same number again square root, and then multiply again by tuple cardinality, and you will get 13.46, that same figure. So estimated number of rows moved now from 1 to 13 if you use this new CE model. But it's not the accurate still, because actual number of rows is 194, but it's better. And now I'll go through another example. Now I have showed you auto create statistics option for the database. Now for this database it is on. What I'm going to do is I'm going to switch off that auto create statistics, so that optimizer will not create statistics for you, just to verify. Okay, So I'm going to check the statistics again for that table. This table is sales soda detail 2. I don't have any statistics, but I'm going to drop this index. I don't have any column statistics. So again, checking that. Verify. Okay. I have only the clustered index now. Now I'm going to use this query, which is select all from sales order detail, where product ID equal product ID, but this is a variable. So SQL Server not uses the value to calculate this. Okay. And I'm using the legacy model here. Oops. It gives you 2 records. And it says the little yellow sign means you can see at the bottom column with the very bottom of this warning, column with no statistics, because now we have disabled or may the switch back to auto create statistics false, so you won't get that auto create statistics. So let's see what is the estimated number of rows this time. Estimated number of rows is 65,000.42. So this time SQL Server does not have statistics to estimate that. Then how you because how SQL Server estimated? SQL Server somehow needs to estimate, because you have given a query and it needs to execute. To execute that, it needs to create the plan. To create the plan, you need to have estimated number of rows. So it needs, now this time there's no statistics present, so it will guess. So how do we guess? So it will take the total number of records of that table and to the power 0.75, this figure. And if you execute this, you will get 65,000. So this is called heuristic. So this time SQL Server doesn't have statistics. So it uses heuristics. Remember, heuristics are not accurate as statistics. So you need to make sure you are not having this situation in your systems. So same query with the new CE model. That's again slightly changed. You can see now it came down to 348, which is better, than the previous one. Now this time again it's a guess, but it uses, instead of 0.75, it's 0.5 for the power formula. And when you execute this, you will get this much. Okay, so let's switch back to our slide deck again. Another one I need to show you. How do you check whether this execution plan has used which Cardinality Estimator model? Okay, you can go to the root level of the execution plan and go to properties. And in this properties, you can see Cardinality Estimator model is 130, which is, if it is equal to 120 or higher value, it uses the new CE model. That's how you need to check. But there are several ways. The other ways are, you can use extended events or plan property window, which I showed you earlier, or else you can get the XML plan and look for Cardinality Estimator model, that text. So statistics maintenance. So how to create statistics? So again, it will create automatically by query optimizer if the auto create statistics option is true. Always single column statistics. SQL Server will not create multi-column statistics. SQL Server always create automatically single column statistics. Remember that. And explicit creation by using create statistics statement you can use to create stats if you want to, and you may want to sometimes. And in this situation, you can create multi-column statistics as well manually. And also when index is created, behind the scene I told you, it will automatically create the single or multi-column statistics, because if you have in your index has 2 columns, it will create the multi-column statistics behind the scene. So how to update statistics? To update statistics also, you have several commands. Or to update statistics, that is a DB option. If that is on, it will automatically update synchronously. That means when you execute a query and execution, the query optimizer detects your statistics is out of date. At that time, it will create the, or it will update the statistics before creating the execution plan. That is called synchronous update. Also, you can auto update statistics off. That means it will be asynchronously update the statistics. Or else you can do index rebuild operation, which will update the statistics again by doing a full scan of your table. Update statistics statement also you can use to update the statistics. Remember, index reorganization does not update statistics, not even index statistics. So these are the various forms that you can use to update the statistics by using update statistics statement. You can include the percentage, how much percentage you can use. Higher the percentage, the accurate the statistics information are. So, but it takes time. But if you just omit everything and just do update statistics table name or statistics name, it will use as the default sample rate, which is very minimum and which is very quick. You can try that. And also you can rebuild index to update the statistics. Or else you can mention you want to update statistics only for the index stats. You can mention full scan, comma, index. Or if you want to say, okay, only the column stats you want to update, auto-generator stats, that's also possible. Or you can mention both. And there are 2 new DMVs introduced in SQL Server 2014, also 2016. You can, for SysDM DB stats histogram, which is actually similar to DBCC show statistics DBCC command that you can use to get the same information. But the interesting thing is you can associate with, you can join this DMV, actually it's a dynamic management function, with other DMVs to, do a lot of queries and things like that. And incremental stats properties has introduced in 2014. It's a new DMV. You can take a look on that too. So just as a recap, before we move on to the question session. So always remember to have up-to-date statistics. That's the key factor for quality execution plan, so that you can minimize the issues that I have mentioned in slide 1. So statistics need to be maintained because it's created by SQL Server and also you created by manually. So those things needs to be maintained. Multi-column statistics can be used to improve query performance when there is no correlation between columns. Okay. Also, there's something called filtered statistics. You can reduce your data set and you can actually address your skewed data distribution by using these filtered statistics, because your histogram can have only 200 steps maximum, and if you have null value, 201 steps. So that those are the steps are there to represent your data. So when your table gets larger, the data distribution will get not normal basically. So you will get skewed data distribution. Then the statistics histogram can't properly get idea about your data. So that's why you need to have filtered statistics. So while many workloads will benefit from this new cardinality model, in some cases workload performance may degrade. So be careful before moving to new C model. You need to test your workload in pre-production environment or somewhere. So use parameters always instead of variables in stored procedures. And also auto create statistics should be on, even though you can make it for false or off in as a database option. But the good thing is uh, it should be on. So consider asynchronous statistics update only if you are facing delays in query execution. Because if you are facing query timeouts or things like that due to statistics update during your optimization stage, then consider using asynchronous statistics update. So explicitly created statistics should be maintained, otherwise they will easily get outdated because they will create automatically. So if you do not maintain it, it will get outdated. So make sure you will in your program you have captured that. So these are some references which I used to make this presentation. There's a Microsoft published white paper about this 2014 Cardinality Estimator. You have very detailed information about that. And also if you need to look at more information about this C model, there are 2 research papers I have mentioned here. You can download that to get more understanding about the inside of CE. So that's it for me today, and now let's open for the questions.
So one of the questions was why 0.75 or 0.5 in estimating the number of rows in the new Cardinality Estimator model?
Right. So as I explained, at that time, auto create statistics is off, so that optimizer will not create statistics. So optimizer has to somehow guess. If you don't have statistics, there's no way to calculate scientifically. So guessing is the only option. That's why they have used arbitrary value 0.5, and they have made it, they have changed that in 2016 to 0.5 to have more better or accurate row count. So there's no any reason, just arbitrary value. It's not a scientific value, it's hard coded. If you don't have statistics, it will use that. That is called heuristic.
Okay, and another question was, what if you use the full sampling option?
Full sampling option you can use, then you will get the histogram information is more accurate, your statistics object is more accurate, it is good for execution plan, you will get better execution plan. But the problem is it takes some time. If the table is really large, like millions of number of records in your table, it gets some time to create that or update that. So in busy system or busy time, you don't want to do that. Maybe in off-peak time, in your stacked maintenance job, we'll take care of that. But in busy situation, I recommend to use less sampling figure and then increase depending on the time it takes.
Are there any changes to the auto update statistics in the new the SQL 2014 CE?
Auto update statistics, are there any changes? I'm not really sure that. I haven't seen that during my reading or preparation of this. I need to have a look again. I'm not really sure about that.
Is it true that the new CE uses, I think it's square root functions in general?
Yes. In the situation that which I showed you
Right.
in the demo.
And why did Microsoft switch to this? Oh, you're a mind reader now.
Because to have better estimates, the reason is when you have conditions joined with AND, the legacy model actually understand as independence. That means those columns are independent. There's no correlation in between columns. But in actual scenarios, in actual data sets, you have correlations between columns. To represent correlations, they have introduced this exponential backoff method. which uses the square root function. So that is the reason to include correlation, because one of the model assumption is independence. Independence means each column is independent. There's no correlation. So in that case, you won't get accurate estimates. That's the reason that they have introduced this correlation in new CE model, which you will get better estimates.
Is it a good practice to create filtered statistics for large tables?
It is perfectly fine. I actually have a separate demo, but I don't have a time to show that, because the filtered statistics you can actually use only for the skewed data distribution, so that it will add skewed part, so you will get better estimates. And also by doing that, you can increase the histogram number of steps, because if you have one statistic, you will get 200 steps, but if you create filtered statistics for the same column, you can increase the number of steps, which which basically you will get better estimates. I can totally show you that. Maybe I can write a blog about it. Or SQL Server Skills also has that detailed information about filtered statistics. I recommend reading that too.
That's great. So you could potentially use it for the large table and not just special cases.
No, because the idea is to use that for a large table, because for large table it will not, because you are not creating any indexes. You just create the statistics object. Statistics objects are very lightweight. You can create less time than indexes. That is the reason. So it is perfectly fine to create for large tables.
Well, that's all for the questions. We really want to thank you for the presentation.
Oh, no.
It went quite smoothly. This session is being recorded. We did have an issue with the recording, so hopefully we have the entire recording, but we'll find out once we convert it. Thank you again, Susantha, and this was a very helpful presentation, and we'll look forward to looking at the SQL Skills article on the filtered statistics.
Sure.
Yeah.
Sure. I actually included that in my
Right.
this presentation as well. Is there any way I can share this presentation?
Yes, if you want to send me your slide deck, I'll be glad to upload that as well. And if
Cool.
you want to,
I will send that.
if you want to share your scripts, if that would be
Sure.
useful,
Everything.
I can upload those. Just send it to Sharon and myself, and we'll get that going.
Sure. I will send everything, scripts plus the presentation.
Okay. Well, thank you again for the presentation.
So thanks for the opportunity. I think maybe some of the attendees might have learned new stuff, and do their own exploration to find out more details. Thank you very much.
Thanks again.
Shall I stop sharing my screen then?
It's muted. Yes, that's fine. I'm just going to save off the recording now.